So now let's look at another case study. Okay. So now this this machine learning model is for um, a HIV data set. This data set is based on this machine learning is based on HIV data set. So first of all, here we import the basic libraries. Okay, we know up to this aspect as the basic library: pandas, numpy, matplotlib, seaborn. Now the last one is a library to check for accuracy. Okay, in the previous video, we didn't do check for accuracy. Okay, but in this one, we'll be checking for accuracy. So we import the scientific learn, that's sklearn matrix. So then we imported the explained variance score, R2 underscore, then F underscore score. Okay, so these libraries, you could use either of them. I think I'll be using R2 score or F1 score, okay, to check for accuracy. So the next thing now is to understand our data dictionary. I told us how important our data dictionary is, very important. So for you, like you don't understand this data set now, when you see the term this, when you want to see this, you know that, oh, this means number of adults and children currently receiving antiviral therapy. And when you see this, then you know that, oh, these are the number of ARC patients with viral load results. Then when you see this, you know that, oh, this number of ARC patients with suppressed viral load results. So this is the data dictionary. Okay, then you could see we have tuna equals to pd.read CSV. Okay, so over here I just imported the data set. So from here I have in the states, I have in the health facility, I have in the different columns for this. So here now I'm going to I decided to rename the data sets some columns. Okay, so I renamed this as patients with viral load. I renamed these as patients with suppressed viral load results. So now when I run it again, you see patients with viral load reports and patients with suppressed viral load results. Okay, so now the next thing is to do the description of the entire data set to see the count. So we have like 85 rows, and I have the mean value for each of these. So if I know that there's a missing value, I could replace this column, the missing value in this column, with patients with suppressed viral load. I could replace them with this mean value highlighted. Okay, so we have the standard deviation, the mean, the maximum, and the percentage based on 25, 50, and 75. So I could do info. Now for the info, I have in object. These objects are strings. Okay, just the way we have states and health facilities. Okay, but these ones are not strings. These are for the values, that is the current receiving patients, the patient's viral load support. So these are integers. So that's what makes us consider using regression model for it. Okay, linear regression. So now let's check for missing value. Don't forget I said we should check for missing value. The initial data, I didn't check for missing value. That is this one. I didn't check for missing value because it was a clean data set initially from an Excel sheet, because I had it all checked out. But it's also good to check for missing value. So that was what I did here. I checked for missing value by saying by doing this. So then now I did a peer plot. So for this peer plot, it shows the correlation between the data sets. So you could see which data sets are more correlated. So like this and this, they kind of look alike. This and this kind of look alike. But the linear are always, diagonal are always the same structure as bar chart, but they're different values. So you print the columns. So now don't forget I said, now please note that if the data point makes a straight line going from the origin, that's the x-axis and y-axis, then the variables are said to be positive correlated. But when it's going but if the line goes from the eye level of the y-axis down to the linear to the eye value on x-axis, the variable are negative correlation. So we could look at this site. Let's look at this site. So negative, you could read more on negative and positive correlation. Okay. Let me see if I could get an image. Okay, yeah, this is it. So this is a positive correlation where it's going from here up. Then this is a negative correlation when it's coming like this. Okay, this is no correlation at all. So since we are dealing with a linear graph, so which is we surely have correlation. So after doing an info, then check patients who are with viral load results and number of patients with suppressed viral. So what I'm doing here is called expository data analysis. Okay, let me pull hashtag EDA. So what is going on here is expository data analysis. Okay, so what we have in here is expository data analysis. I'm trying to explore the variable. Okay, so I'm trying to plot in X. I'm trying to plot in patients with viral load results and patients with suppressed viral reports. So I'm trying to compare two columns to see. I'm trying to compare two columns to see what I'm going to get. So I have this. It shows that it's linear. Wow, that's a good progress. So I could get the dependent and my target variable. So now what I'm trying to do is to identify my target variable and dependent variable and prepare for training, for data training. Okay, so now I have my X variable. For my X variable, I have patients with viral load and currently receiving viral. So what I want to predict is the patient with suppressed viral results. So what's the possibility of having more patients with suppressed viral results when they are already on viral load results, when they have when they are patients with viral load results and currently receiving viral reports. So what's the tendency of having the suppressed viral results, more suppressed viral load results? Sorry for that. Okay, so what we do is splitting. So we import from scientific sklearn, we import print test split. Then after importing it, don't forget I said this code, you don't have to cram it. Just know we have X train, Y train, X test, Y test. Okay, then we import this value, this here, we bring it here. I'm calling our X and our Y variable that have been created here, X value here, Y value here. Okay, then the test size, I give it 0.2. Okay, so you put it 0.2 or 0.3. 0.3 means 30%. You are splitting its size, you are splitting the data by 30%. You could split by 20%. Okay, so after splitting, you see that I printed the length here. Okay, so the length is printed for us. So we have 68, 68, 17, 17. Don't forget we said the training set has to be higher than the what? Test set. So if you can see here, we have the train set. We have the train sets. So the train sets are 68%, which is higher, far higher than the test set, which is 17. Okay, so now linear regression model objects to hold. So what we do now, we feed in the model. So I told us about logistic regression. So we could import logistic regression, linear regression, but in this case, I'm using linear regression. So for linear regression, I said Bob equals to this. Okay, so Bob does fit X train and Y train. Don't forget our train, either X train and Y train, they have large percent. They have 68%. So they have large percent of the data set already. So now we could work with them. So after fitting it with the data set, I could check the accuracy. So now this is where the accuracy comes in. So if I say Bob.score, now Bob.score is this model. This score is from this place where I imported this library. Okay, where I imported this library. So Bob.score now is checking the accuracy of the model. Okay, so I have like 99% accuracy. Okay, so if you keep on running this, you could have different accuracy. Okay, it might be 98, 94, might just start changing. So we could check for the covalent, intercept. Okay, we could check for intercept for it. We check for coefficient of it. I explained that in the previous video. Okay, now let's look at the prediction model. So for prediction equals to Bob does predict X test. So don't forget I said we're going to predict X test, and we're going to predict X test. Don't forget I said we're going to predict X test with X test, and we're going to compare X test and Y test. Okay, now that's what we are doing. Okay, we are predicting X test. So our X test here is our X test now. Our X test is now equal to predictions. So when we print predictions now, we have our predictions at this, and we have our y test and this. Okay, so don't forget, can you see we have complex numbers in between them? We have negative complex numbers. Okay, so now how do we know that what we've done is correct? Now, this might not really make sense to us, but when we are integrating this to a mobile app or to a web app or to a software, to a system, it's the work of the backend. So a lot of people use Django or Flask for integration. Okay, so integrate this model, you download, probably you export it in a Pico file. So if you plan on going far or exploring the machine learning aspect, you find it very interesting, that's good, that's great to hear. So you could dive in, you could learn more on machine learning. There are various resources on the internet to learn machine learning, or you could offer some courses, or you could come back to us to learn more about machine learning, or you could offer some courses online to learn more about machine learning. But definitely, for now, it might not fully make sense, but the integration will make sense when you have an interface, let's say diabetics, or let's say fitness prediction. Okay, so let's look at, so we'll do a scatter plot between the y test and x test. What the prediction is the x test. So we have a linear graph. So this shows that we have a best fit of line. Okay, so we could do KDE, this plot. All these are the statistical aspect. If you are into statistics, you should understand this aspect, but it's just the mean absolute error, mean standard error, matrix error. So mean is the easiest to understand because it's the average error. So the average error we have, we could check them out. We could check the popular mean squared error, the mean squared error. We could check them also. Okay, so that's that for that. So let's look at the last. So we should be familiar with Titanic data set. Titanic data set is an inbuilt data set, okay, for in Seaborn. Okay, so we could predict the survival rates, predict whether a person survived or not based on the number of factors. So there are a lot of factors. First, we need to remove the columns which not necessary for our model. So like passenger ID, name, all these are not necessary for the model. Okay, so let's look at, for example, this is not the actual data set, because if you import, if you try to check Titanic data set, you see that it has tons of columns for it. But we removed all these. So you see this like this. Yeah, we're going to remove them. We'll not be using them. Okay, they're not necessary for our model. Okay, so we're going to be removing them. So we're going to drop them. So we're going to drop things that are not needed. So drop insignificant variable. So over here, we'll drop insignificant variable. So if you know that a variable is not needed for what you're doing, so now what we have now is the data we want to explore. So this is the data we want to work with. So we want to predict the survival rate based on the classes. So this P class means passenger class, either first class, second class, or third class, and on the Titanic ship. Then we talk about the gender, the age, the fare. So based on the fare, based on your ticket, that is the amount you pay, you know, it's possible you'll be on the first class, or so. Like for example, this guy paid like 71. This lady paid 71, the female on a one, which is the first class. Why this person paid like 7 point something, and the maid is on the third class. Okay, so I could describe the data set.info. Now we notice we have integer, float, and we have just one object. Okay, we have just one object. So we could do a pair plot for this. So we could do also, we could do a mass plot lib. So this is a mass plot lib. I told us to explore the different styles we have in Seaborn mass plot lib. So these are styles in Seaborn. So Seaborn white grid is a style. Okay. So PLT does figure. This is from mass plot lib, and this is from Seaborn. Okay. So we combine the two together. Then, so for this we have. So now we could check. We are checking for missing value. So can you see now we have missing value for age 117. So can you remember saying replacing missing value with the average mean? So we could replace missing value with average mean by saying .fill NA NP .random good. So all this we're replacing with mean .mean. So this .mean is going to replace the missing value. So now when we check again, so in place equals true means permanent. If you can remember from our previous classes. So in place equals true means permanent. So when you do this now, you see we have all we have no missing value. So these are our data sets ready to kick off into the machine learning sector. So now we're moving into the machine learning sector. So now for the machine learning, we did the data dictionary here. So P class, when you see P class, know that we're talking about passenger class, or first class, second class, or third class, gender. We've talked about fare, that's the amount paid, the age of the passenger. So that's that for that. Now X equals to, so now X now is what our independent variable, okay, because it can stand on its own. So the P class, sex, and this, while our target variable is Y, which is the survived. So we want to know how many people will survive. For someone to survive in a Titanic ship that is about to crash, it depends on the age of the person. The people could say, okay, because you are old, you are very young, little, they will say, okay, children and mothers should go in first, or based on your gender, or based on the amount you pay. So if you pay each amount, you have, because you have money, you buy the entire ship, so you say, oh, you have to go in first. So if you've watched Titanic, you remember what happened in the movie. Okay. So so for encoding, so for this for our sex, which is the female, we have to encode it. There's something called encoding. You know, for men and for sex, which is the gender, is categorical. It's either male or female. Okay, so we could transform it into numbers, into binary, either ones or zero. So we are encoding X because of some variables that are alphabet. So because when we do .info here, when we do .info here, when we do .info here, you see we have our set as object. And object means string, so we can't work with anything. Don't forget, linear regression deals with continuous variable. And when we say continuous variable, we are saying numbers. So anything that is not a number is not going to. Anything that is not a number is not going to work. Okay, anything that is not a number is not going to work. So we are working with continuous variable. Okay, so the next thing for us to do is to convert that category, that string into numbers by encoding them. So what we do now is to encode it into ones and zeros. Okay, so what we did is we imported sklearn preprocessing import label encoder. So Bob equals to label encoder. Now X of sex equals to Bob dot fit transform X of sex dot tail. So now if you see, now you can see that sex is equals to 1001. So 1 stands for male, 0 stands for female. So let's just look at this. Yes, 1 for male, 0 for female. So now let's look at splitting. So we import this as usual. Just import this as usual. Do this as usual. X and Y. That's what we splitted. Our Y is our survival. Our X is this, or this the independent. Okay, so now the next thing to do is to split. So we split it by 20%. Now after splitting, we see we have 712,791. Themselves 179. Sorry. You see that the difference in them is very large. One is 700 and something, while this is 100. Okay, so it's to some extent our training set is larger than our test set. Okay, so the next thing is so over here we're using decision tree. Okay, we use decision tree, we use linear. Okay, so decision tree also is also for linear regression. Let me show us here. Okay, so it's also for linear regression. So for regression, we have decision tree also. So we are trying to use decision tree here. Okay, so let's see. We have, so from this, okay, there's an error here. Okay, so just ignore the error. The reason why I didn't run it is because There's some libraries that I have to install that are not still installing, so that's why I didn't run them, but I've run them before, so that's why I just left them without running them. So for here, if you see after doing CLF of score, you see we have 76%, okay, which is good. Don't forget I said like 70 upward is good. So to print our prediction, also we could do accuracy. So there are some matrices we can use for accuracy. So scientific learning matrices, we have this classification, reports, confusion matrix. So we could use this for prediction, so to check our accuracy. So for precision and recall, F1 support. So all these are types of accuracy. So we could check 79, which is good, 83, which is good, that's 83%, 79%, 81%, which is good. So we have good accuracy. Okay, so we could do three visualization. We could visualize them. So the reason why I'm still having all these errors is because I have some modules, some libraries that are not installing. So this can be like the annoying part of data science, where you are trying to install a library, but you are not getting an edge over it. Okay, so that's about it. So we could also use random forest. Okay, we could also use random forest. All you just have to do is to say from this import random forest, random forest classifier, then fit X train and Y train. We have this, but because to B does predict X, then confusion. So literally, it's easier to use any library of your choice, depending on what library you want to use. Depending on what library you want to use any library of your choice. So just the way we have in here, the method we use, the one we use under random forest is this one. That's the example methods. So if you come back here, if you see we said from example, right? Scientific learning example import random forest. So that's why we said scientific learning is a very powerful machine learning model that is used for prediction. Okay, so all these predictions shows that what we've done is good. Okay, so we could see our predictions for this when we print our predictions. So you can print your predictions to see what the output is like. Okay, so that's all for our machine learning. If you have any questions regarding some aspects, let me know so we can resolve them together. Thank you very much, and have a lovely day.